All right, so the first thing we're going to talk about are the two types of measurements. So any measurement that you can think of is either going to be considered a vector measurement or a scalar measurement. So raise your hand if you've done vectors in math class. A lot of you probably have done vectors in math.
I've done it in Adobe Illustrator.
In Adobe Illustrator? Who's done vectors before? Okay. If you haven't done vectors before, we're going to go over them pretty thoroughly in a couple of weeks. But for today, I just want you to understand what it means to say that a measurement is vector and what it means to say a measurement is scalar. So vector measurements have what we call magnitude. They have a magnitude and a direction. So direction you can all wrap your brain around pretty well. There's two main ways you're going to see directions given. Directions can be given as north, south, west, and east. So we'll see problems, where the direction is specified using that frame of reference. And then the other way is what you do in math class. How do you specify directions in math? With X and Y. The object is moving in the positive X direction. The object is moving in the negative Y direction. So these are referred to as frames of reference. Okay, so there's two main frames of reference. Now, magnitude is a number, or it's a term that for some reason stumps a lot of kids. You're going to see it on quizzes and tests and the homework. The problem would say, find the magnitude of the acceleration. Find the magnitude of the force. So all magnitude is it's how big, how far, how much, how hot, how what? How fast, how awesome. If you're ranking something from 0 to 10 and you're like, oh man, that movie was a 9 out of 10. That's a magnitude. Basically it's the size of something. Does that make sense? And notice both vector measurements and scalar measurements have magnitude. Garrett.
So would measuring an earthquake, that would be a scalar measurement, right? Magnitude only.
Yeah, exactly. It's magnitude only. Yeah. So if you're talking about the size of something, it's magnitude. Now, if you have magnitude with a direction, you're talking about a vector. If it's magnitude only, then it's scalar. This will make more sense as the weeks go on, but for right now, I want you to remember, of the two, which one is going to be more of a pain in the butt? Vectors or scalars? Vectors. Look, in the world of scalar, 5 plus 5 will always equal 10. Hey, is money scalar or is money vector? Scalar. Can you put a direction on $5? No, that doesn't make any sense. In the world of scalar, 5 plus 5 will always equal 10. How about in the world of vector? In the world of vector, 5 plus 5 can equal anywhere from 0 to 10. Anywhere from 0 to 10 is 5 plus 5. It depends on what? The direction. So when would 5 plus 5 be 0 in the vector world? Well, what if you had a vector that points to the right? That's 5. And then you had a vector that points to the left. That's 5. What are those two vectors going to do? If one points to the right and the other one points to the left, they're going to cancel to 0. So when would 5 plus 5 equal 10? Well, that would be if you had 5 to the right and 5 to the right. Then those will be what? What's that going to be? 10. That would be 10. And then what if you had this? What if you had 5 to the right and then 5 pointing up like that? What would the answer be there? The answer would be the hypotenuse. Okay? So direction is really important when it comes to vectors. And like I said, we're going to spend a good 2 or 3 days just doing vector problems, just so you guys get comfortable with it. Okay? So let's do a few examples here. Okay, so I picked out a few things. So time. Would time be vector or scalar? Scalar, because you can't put, if I said, bake the cookies for 10 minutes east, does that make any sense? No, you don't put a direction on time. That doesn't make any sense. Okay, how about, let me erase this. How about temperature? Scalar. You do not put a direction on temperature. Outside today it's what would you say, about 70, upper 70s? 80 maybe? 80 degrees. You don't put a direction on temperature. It doesn't make any sense. All right, how about force? Vector. Now, by the way, we're going to spend a whole chapter on force. You're going to learn all about forces. But what is the definition of a force? A force is any push or pull. So you can put directions on a push. Which way are you pushing? Are you pushing north? Are you pushing south? So here we got this guy pushing on his car. Does anybody know the unit for force? The physics unit for force is the Newton. What do we use in everyday life for force? Pounds. Pounds is what so a Newton and a pound, they do the exact same thing, right? And the conversion is 1 pound is about 4.5 newtons, roughly that. Okay, so that's going to be vector. Force is vector. And then the last one, we're going to be talking about acceleration. So you guys have an idea of what acceleration is? If an object is going faster, 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 that's an acceleration. If it's going slower, 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 that's a deceleration, also known as a negative acceleration. But can you is there a direction on acceleration? Yeah, if you look at this jet taking off of that aircraft carrier there, which way is the jet accelerating? Is there a direction to its acceleration? Yeah, forward to the right. This guy is accelerating that way, off the aircraft carrier. So any measurement with a direction is vector. Okay, now there's one tricky situation. Let's see. Or some tricky terms here. So 2 terms that have a very similar meaning. So you've all heard of distance, What's the distance from here to there? That's what we would say outside this room. A word you may or may not have heard of is displacement. Have you guys heard of displacement? It's a very common term, like in chemistry with fluids. You have like a beaker full of water and you put a rock in the beaker and the water gets displaced. The physics definition of displacement is its change in position. So this word displacement here, another name for it is change in position, which is often written as delta x. So what is delta in math? Change, and then x is the position. Okay, so I have this map of California. So we're down here. There's the PV Peninsula. Okay, so we're right here. So say we go on this journey, and this journey is going to take us, so we put our frame of reference, north, south, west, and east. So say this journey has 3 parts to it. So the first part, we go directly north, okay, and then let's say that is, how far would that be, like 100 miles, you think? Let's just say that's 100 miles. Okay, so 100 miles north. Then we go directly east for 75 miles, and then we come south for 100 miles. What would be the total distance? So just think in terms of everyday life. We go 100 miles north, 75 miles east, and 100 miles south. What's the distance we traveled? 275 miles, right? Distance is scalar. This word here is scalar. So what does scalar mean? Does it care about direction? Nope. Distance is scalar. Does not care about direction. Displacement, on the other hand, is vector. What does vector mean? It cares about direction. So like we just did on the previous screen, who can tell me what's going to happen to this 100-mile north and this 100-mile south? They're going to cancel each other, right? So what is our displacement, the delta x? What will our displacement end up being for this example? 75 miles, which way? East. So the thing to remember, to make this real easy, so displacement only cares about the starting point and the ending point and the shortest distance in between. What's the shortest distance between the start and the end? 75 miles. And which way is that? East. Okay? So displacement's vector, distance is scalar. Okay? All right, so we'll pick up here tomorrow. There's no homework because we haven't gotten far enough in this. In fact, I have the next homework pack ready, but I won't even hand it out today.